Welcome to Maths and Science by IITian channel. In this lecture, I will be taking up a 5-digit number 2 to the exponent of 5-digit number, 2 to the exponent of 5-digit number, and we will be finding the remainder when 2 to the power of that 5-digit number divided by the 5-digit number. What will be the remainder? That is, we will find sum of the two exponents when divided by a 5-digit number 99929. What will be the remainder? X is the remainder. It is a problem from congruence, modular arithmetic, and congruence modulo theorems and Fermat's theorem. Fermat theorem. And also, to apply the Fermat theorem, we are required to find out whether this particular number 99929 is a prime or not. To check a number as a prime, there are some 3-4 concepts involved in it. One is to check whether the given number is a prime number or not, whether Fermat's theorem is applicable or not, and some of the 2 to the power of large exponents, and to find the remainder. These are the concepts which we require for solving this question. The question is 2 to the power of 99,929 plus 2 to the power of 99,930 equivalent to x mod 99,929. We have to find out the value of the x, that is the remainder. In other words, 2 to the power of 99929 plus 2 to the power of 99930 equivalent to x into mod 99929. To solve this, the first step is to find out whether 99929 is a prime or not. Let's delve into the problem. Question is, find x if 2 to the power of 99929 plus 2 to the power of 99930 equivalent to x mod 99929. Here x is the remainder. Solution. As per Fermat theorem, a to the power of p minus 1 equivalent 1 mod p. This is what is the Fermat theorem. We try to apply this Fermat theorem. To apply this, here there is no direct value of a to the power of p minus 1 on left hand side, and there is no direct value of 1 mod p also on the right hand side. We may have to reduce this particular equation to this to find x, or we may have to deduce the given values from the Fermat's theorem and find out x. We have to do that. Now, here first step is, here p is prime Our given number P is 9929. 99929. Is it prime? First and foremost, this is the first and most important concept which you have to know before applying the Fermat's theorem. Whether the given number for which mod is being found out, congruence is being applied, or Fermat's theorem is going to be applied, whether that particular number is prime or not. Let us find out. The given number is, let us say P 99929. It's a 5-digit number, a big number, which we cannot easily find out whether the number is prime or not. But the best way to find out is find the square root, that is square root of 99929, that is equal to 316. Find the primes between 2 and 316, that is equal to 65 primes are there. It's not a very big number, impossible number, it is not very large that you cannot do it. At the same time, it is not a small number where you can do it with ease, but we are required to take some extra efforts and try to divide this number 99929 with the primes between 2 and 316. That implies no prime is a factor of 99929 between 2 and 316. That implies, I am going first because I have already explained the processes of finding the prime, whether a given number is prime or not. There are various methods available. Please refer to my earlier lectures and understand how to find out the given number is a prime or not. Now, this is construed as that 99929 is a prime. Now, we have got the input that 99929 is a prime, and Fermat theorem for prime numbers, Fermat theorem is a to the power of p minus 1 is equivalent to 1 mod p. That implies a to the power of 99929 minus 1 equivalent to 1 mod 99929. Here, that implies from Fermat theorem some a 99928 is equivalent to 1 mod 99929. Whereas p minus 1 is equal to 99928 is equal to 99928 is it divisible by 2? Just see, 99928 is it divisible by 2? Yes. 2 into 49964, again it is divisible by 2. 2 into 2 into 2, 4982, again it is divisible by 2. 2 into 2 into 2 into 12491. These are the factors for p minus 1. Here, let us take the smallest prime factor 2. If a is equal to 2 and AP, the GCD of AP is equal to 1, because GCD of A is 2,999,29, that is equal to 1. Here P is equal to 99929, P minus 1 is 99928. Hence, Fermat theorem can be applied. First, we have found out whether the given number is a prime, and for p minus 1 we have found out the factors, and in that smallest prime factor we have taken, and we have seen that particular value of a, we have taken it as a, whether a and the given number which is prime, the GCD of both of them is 1 or not. Yes, the GCD is 1, then we can apply the Fermat's theorem safely. What Fermat's theorem implies? A to the power of p minus 1 is equivalent to 1 mod p. That implies 2 to the power of 99928, because p minus 1 is 99928, is equivalent to 1 mod 99929. But we have to find out 2 to the power of 99929 plus 2 to the power of 99930. We have got only value for 2 to the power of 99928. This implies 2 to the power of 99929 is equivalent to 2 into 1 into mod 99929. And 2 to the power of 99930 is equivalent to 2 into 2 into 1 into mod 99929. From these two we get that 2 to the power of 99929 plus 2 to the power of 99930 is equivalent to 2 into 2 into 2 into 1 into mod 99929. That implies 2 to the power of 99929 plus 2 to the power of 99930 is equivalent to 6 mod 99929. That implies the given question is, that is compared with the given question 2 to the power of 99929 plus 2 to the power of 99930 is equivalent to x into mod 99929. Comparing these two, we will get the value of x is equal to, therefore x is equal to 6, implies x is equal to 6. That implies 2 to the power of 99929 plus 2 to the power of 99930 is equivalent to 6 mod 99929. Hence, x is equal to 6 is the answer. In this example, we have tried to develop the concepts for finding the number whether it is a prime or not. Once it is decided that it is a prime number, then for p minus 1 we have found out the factors and we have taken the smallest prime factor and we applied the Fermat's theorem there. That we have taken it as a and we have seen that whether a and the given prime number, does it have any common divisor. Then when GCD is 1, we safely applied the Fermat theorem where a to the power of p minus 1 is equivalent to 1 mod p, where p is the given number which is prime, which we have proved early, and then a we have assumed as 2, which we have taken as the factor of this particular number, and we have found out 2 to the power of p minus 1 equivalent to 1 mod p. From there, we have converted that particular Fermat's equation, we applied that Fermat equation to the given problem and we got that 2 to the power of 99929 plus 2 to the power of 99930 is equivalent to 6 mod 99929. This is the answer. With this, I want to close this lecture now and best of luck to everybody. Thank you for listening to me. Thank you for viewing my lecture, and if there is a value addition to you because of this lecture, kindly share and subscribe to my channel Maths and Science by IITian. In mathematics, it is not only that we know the theorem, it is how best we can apply that particular theorem to the given question in the examination is the most important. Please do better. Best of luck to everybody. Thank you.